Okay, so we talked about the battery, and the realities are that you can get 100 to 200 cycles from a $200 lead acid battery, and 4,000 to 10,000 cycles out of a $1,000 lithium iron phosphate, a LiFePO4 battery. So that is what I'm going to be working with, and this is the list of what's in our system. And usually, there's actually more, but this is the list we're going to work with for this class. It's enough to mess around with a simulator that's going to simulate the system. And you get to build a couple pieces of this as a homework exercise. The nice thing about it being a simulator is you don't have to have an entire, Mercedes Sprinter van to test it, or a solar system. I will provide you with some data. But the piece that we're going to take a look at is just the switches to start off with. But the pieces we actually have to play with is we have an air conditioner that we can cool the battery, and there is a way to turn that on and turn it off. A way to turn on a heater. This can be turned on by the computer. A temperature sensor for the battery, for the outside air. A sensor that says when the charger is providing electricity to charge the battery. A different sensor that says when users are using electricity. Some switches. Okay, they can turn off the charger. They can turn off the user to protect the battery against under discharge, overcharge. A fan in the battery compartment. The battery itself, and a battery charge sensor. How full is the battery? So we're going to build some pieces of this as objects. And the first pieces I'm going to look at, okay, this is the set of objects that I think we're going to build. As I said, I think because we are in the process of building it. But this very first set of things is the stuff we are going to mess with first, which is these objects. And all the switches are going to inherit from switch. So we're going to have a charger switch and an output switch that we can turn on and off and ask if it's on or off. So let's take a look at those at the code. And there's several things we want to point out and work with. The first is we're going to implement something I'm going to provide you with is called simulated system. And simulated system has the ability to turn on and off the physical devices. It provides us with the input that allows us to run stuff over time. So we have a switch, okay? Remember, in objects, you have some sort of initialization that sets it up to start off with. It has a function isOn, a method isOn that says, well, is this switch turned on right now? There's a turn on and a turn off. And then there's this funny piece of code that looks like this that you just have to learn for Python that says, by golly, in this thing with class switch, is it the code that runs if you just run this file by itself? So this is where we put our test code inside this if, with this funny thing to see if it is the main program as opposed to being imported. And you notice that we have an import here. Now this import is a file that I'm going to provide that's going to be simulated_system.py. And when you do the import for it, you just list it. Okay? The key piece here is that here in a second, we're going to build a second class that inherits from switch. And the second class that inherits from switch is going to import switch, which means that this code that you're looking at right here, which I'm going to provide you with, is got to be in a file called switch.py in a directory. So you have to go and create a directory, create a project in Visual Studio, create a directory, and in that you have to put this file switch. And you also have to have in the same directory a simulated system file that I'll also provide you with. Now, the two switches are very similar. I'm actually going to go and edit those. Output switch, and you notice that it has import switch, which is the code we just looked at, which means we get all the things that are in switch. And where do we find import switch? We find it from the switch import, and it is called switch. So the output switch imports this thing from another file. When we look at it, we have an initialization. We say we want to import, or we want to set up this myAddr, which is just a constant 2 because in the set of stuff, that's where the output switch is at location 2. And the super initializes the base class. So we're probably going to do some more tests than this, but this is our starting point. The other switch looks just like this, except it has an address of 1 right here for both of the addresses instead. But basically, this lets us implement and test a piece of code that works with a switch, and then use it multiple times as an inherited object. So this is where object-oriented starts to take on meaningful usefulness, when we actually start tying it to real-world things. So, we are going to have a homework exercise. It's going to be coming up. I will probably have it out tomorrow, where I provide you with the different things for this first set of stuff, which is to build an object in this system, and also to do some testing of these existing classes. Now, you're going to get a couple different test files. And when you get the test files, those test files have data in it that runs over time. And a main program that takes this and creates the objects and runs them over time so that you can test with it. We'll walk through that in Visual Studio Code and how it actually works. But basically, this is what we're going to do, is build some classes and test some classes, matching with a scenario out of the real world. Now, for actually building this in the real world, this is how I would go about building this. I would simulate some data, I would build out the code and the classes, all with simulated data. Then all of this stuff would actually go on to something like a Raspberry Pi that actually has the ability to control circuits, and I would actually test the electrical system in the Raspberry Pi and make certain that it works before I actually hook it up to my solar system. And then it's going to turn on and off relays that in turn turn on and off things. So there's the hardware piece of this, but we're not going to spend too much time looking at the hardware. We're just going to mess around with the simulated system and test it with that.